Hello everyone, this is Iman Sheikhansari. In this video, we will cover what is sky matrix and how we could do radiation analysis. As you might remember, for start, we need to have an EPW file. So I bring up my Ladybug download weather. Here it needs weather URL, which you could get from EPW map. I have my let me bring up the EPW map. I copy the link here. You could access it through the Ladybug tools or from Canvas. Okay, I have got it copied and weather file URL. Next thing, we should import those EPW file data into our canvas, and there we go. So in order to calculate cumulative sky matrix, we need to go to second subtab and Ladybug cumulative sky matrix. What it needs location, it needs diffuse horizontal radiation and direct normal radiation, and there it goes. But you don't see anything on canvas. It's because we need Ladybug sky dom to visualize this sky matrix. And here we see it. So in order to see the diffuse and direct radiation sky, we need to toggle bring up a boolean toggle and toggle here and turn it to true. So here you could see we have our diffuse radiation, direct radiation, and sum up of these two as a total radiation. As you see, the diffuse radiation is very low. It's about, I don't know, somehow around 20 kilowatt hour per square meter, and we have some huge radiation, about 70 kilowatt hour per square meter as direct radiation. One of the cool thing you could do is bring up sun pass and toggle it in, and you see how sun pass affect our sky here. So in order for me to have a better visualization, I could bring a boolean toggle and wire it to high density and turn it to true. Now you see a more high density visualization here. And there we go. But what these kilowatt hour per square meter talk about is the sky. But I want to calculate the effect of the sky on my geometry. So I hide these and bring up Ladybug incident radiation. So in order for me to have it better and visual secure. So what is mandatory here? It needs sky matrix, geometry, grid size, and run it. So as you might remember from the previous video, Ladybug sun pass, Ladybug's direct sun hours, it's almost the same. So I bring up a geometry, and here I draw a box which is 10 by 10 with the height of 10, and set one geometry, wire it in, bring up a panel type 1 as a grid size, and bring up a toggle in order to calculate this. I usually parallel in order to calculate for calculation. Use all of my CPUs. So I turn it to true, and there I see how much radiation each surface of my geometry would absorb. And there's a very cool thing about this. If I zoom it in, you see here my roof actually absorbs about 2000 kilowatt hour per square meter. And there's a very important thing, it's the calculation of annual time set. You know why? Because here, as you might remember, we calculated cumulative sky matrix, which means for hour of a year we put whole year in it. As you see here at the last line, is that by default the matrix will be for the entire year, which was not the same for our sun pass or Ladybug direct sun hour. But what it could be used, this analysis is for solar water heating system, photovoltaic panel. I could now easily choose my roof. Let me explode this and set my roof as a geometry, set multiple geometry. And here I see my roof absorb about 2000 kilowatt hour per square meter. If I, here I have the total result of it. If I multiply this by the efficiency of my solar panel, which would be about, for example, 20%, I could now understand how much energy it generates if, there's two things, if I put photovoltaic panel on my entire roof. And there is a very important thing here too, which is our unit here is kilowatt hour. It doesn't talk about per square meter. If I want to change this data to the square meter, I should bring up a division and divide this number by the area of my geometry. There I see a more comprehensible result. Over the whole year, and square meter of photovoltaic panel or solar water heating system with efficiency of 20% could generate about 400 kilowatt hour per square meter annually. And of course, I could divide it to the days and see how it goes. But another thing I want to cover in this video is that how much our incident radiation is different to our direct sun hours. So let me join this and have it copied here and there and there. I copy them regularly so you could see the effect. I want this geometry to be calculated, so I bring up set one geometry, I hide this, and let me have it a little bit clearer. I toggle this geometry here, bring up another geometry for the context, set multiple geometry here, and context, and this context. So as you see, it calculates the effect of my context neighbor on my result. So let's see how it's different from direct sun hour. So I could wire the sun vector in, the grid size from here, run it, and parallel. So as you might remember, I mentioned it. It said sun vector failed. Why? Because here we need hour of there. So I bring up my analysis period and have it wired in. Here you see the effect of sun hour and incident radiation. So I bake these two to see it parallelly and see how much they are differ. I move this here and hide this, and I bake this and move this beside. So in order to have it better seen, I go to my rendered view because I don't want those meshes to be seen. And here you see it's the graphical preview is almost the same, but you see some difference here. That is the result of the diffuse radiation that we have. And of course the units are different, but I mean, because the effect of my radiation and mostly based on the direct radiation sky, my total radiation is from my direct sky. Here the results, at least graphically, almost the same. And another thing I want to cover in this video is that we could have, by ladybug hourly plot, have this, for example, direct or diffuse horizontal radiation on an hourly plot in order to better understanding. So I go to top view, I hide these, and hide of course these, and we have see it's watt-hour per square meter. And here you could see your direct normal radiation, which is correspondent to how much your facet in each square meter absorbed the radiation. And here you could more clearly see the effect of sunset, sunrise and sunset here, and how much radiation here. You see there are some part which is missing, and this is corresponding to the thing we have here, which is total sky cover. If I bring it in, here you could clearly see how much of the sky is covered, for example, by cloud or anything else, and these really affect the absorption of radiation from the sky. Usually these data have some anomalies because weather station didn't take it seriously, but you could see how much it relies on each other. I hope you enjoyed this video and do a very, very great thing with this radiation and cumulative sky matrix.